So R represents that one fixed distance to the center. So be careful, if that's an X, that varies. And then finally, we need this height. Is that a horizontal or vertical distance? Vertical, what letter measures vertical things? Y. So the bottom is at y equals 0. So all my strips are on the x-axis. And the top is on the circle. So the equation of that circle, which we conveniently worked out beforehand, here is a picture of what one of the slices is doing. A little slice, a little rectangle in the original graph is giving us a shell. And when all these shells are stacked together, we end up with our entire shape. So what I'm going to do is I'm going to unroll that shell. So if I unroll it, I get a big slab like this. Got the circle here. I cut it in the front and peel it open like that. So this thickness is the dx. This vertical distance is this vertical distance here, which is given by the y. And that's little r squared times big R squared. And just like the previous problem, is when we unroll it, the base of that slab is the circumference of this circle. So the radius is x, the circumference is 2 pi x. So the volume of this little slab is 2 pi x square root r minus x minus r squared dx. And then we have to add these up. Are the slices indexed by x values or y values? X. So we have letters here instead of numbers. What's the x value at the far left of the circle? The way I think about it is, if I travel a distance of big R, that gets me right to the center. And then if I go back the radius of the circle, if I go back little r, I'm at the far left. And what's the x value for the far right of the circle? Big R plus an r. So we go big R to the center, and then another little r, the radius of the little circle, to get to the other edge. So my limits of integration, big R minus R, maybe there's some technology that can do this. If not, how would you do this? I can probably get away with the W substitute. Yeah. At least a trig identity. So you can match it with the 1 minus sine squared. As far as the exam is concerned, that's as far as you need to go. Luckily, I'm giving you a lot of time. I mean, how long? It's been a couple weeks since we lectured on 6.3 versus 1.2, right? We've had plenty of time. Anything else come up in the homework? Yeah. As long as it's short. And so this is another surface area problem. You know, why don't we do this one together? On this one together. As in, I'm going to write the problem on the board. You're going to do it similarly to the surface area problem I just did, and then we're going to do it together. You haven't done the homework yet. Let's do it this way. So either we'll take the 10-minute break, or if you want to work on this, you can use the break to work on it. And then after the break, I'll come back and show you how it's done.